Excellent!
What's up guys, how's it going, and welcome to my first ever Radeon RX Vega review. AMD's new GPU line launches today with the Vega 64 and the soon to be available Vega 56. I'm going to be focusing on the Vega 56 today, which is retailing for $399 and is intended to compete with Nvidia's GTX 1070. I do have the Vega 64 as well, which is going to retail for $499 for the standard version. At least it looks like this. What I have here is actually the brushed metal finished limited edition version that you can get if you purchase a Radeon pack, but I will put links to the Radeon packs as well as the individual cards in the description once they become available. In another day or two, I'm going to be coming back with a video follow-up on the Vega 64 benchmarking numbers. For today though, I'm going to be focusing on the Vega 56 versus the NVIDIA GeForce GTX 1070, so let's get right into the testing setup. My test bench is composed of an Intel Core i7-7700K CPU running at 4.8 GHz. The motherboard is a Gigabyte Z270 Aorus Gaming 5. The water cooler is a Corsair H110 280mm all-in-one liquid cooler. And for memory, I have a 2x8 gig kit, 16 gigs total, of Kingston HyperX Predator DDR4 running at 3200 speed, cast latency 16 in dual channel mode. For storage, I have my Windows 10 operating system on an Intel 600p 512GB NVMe SSD. Games and video files are on an external SanDisk Ultra 2 1TB SATA SSD connected via USB 3.0. Finally, for power, I have a Corsair HX 1000i 1000W 80 plus platinum power supply, and it's all on an open test bed. So for comparison, I have the Galax GTX 1070 EXOC Sniper, and this is a manufacturer overclocked third-party reference design version of the GTX 1070. This is the ultimate benchmarking question when you have a new graphics card like the Vega 56. What should I compare it to? AMD, of course, would prefer that I compare it to the GTX 1070 Founders Edition, but that's running at stock frequencies. At stock, the GPU runs at about 1850 MHz peak, 1750 MHz stable under gaming load, which just seems a little bit slow given how well the 1070 actually overclocks and how many third-party designs are on the market that you can buy that already come pre-overclocked. So I chose the Galax GTX 1070 EXOC Sniper for this reason. It has a healthy manufacturer overclock, it peaks just shy of 2000 and was running at about 1962 MHz under load. Given that the 1070 has been out for over a year already, I think this modest concession to the third-party versions that are available is fair, but feel free to use the comment section down below to tell me if you disagree as always. The GPU driver I'm using is the latest from NVIDIA version 384.94, and I have press provided drivers for the Vega cards. I'm using Hardware Info 64 and the AMD Radeon settings utility to monitor statistics. AMD also delivered a new driver and software build on Saturday with some updates for overclocking support, and although we weren't supposed to use that build for comparison testing, I actually got some pretty solid results with it, so I have included them too. Now with early hardware and software, monitoring can be touchy, so here's how I overclocked with Radeon settings, using the Wattman utility under global settings. Manually entering the frequency just wasn't working at all, so I used the percentage slider. I started with a 10% overclock that I eventually dialed back to 9% due to some instability. I maxed out the voltage where possible. I bumped up the 8 gigs of HBM2 memory from 800 to 900 MHz frequency. I set a much more aggressive fan curve maxing out at 4500 RPM, and I set the power limit to plus 50%. I'm not completely sure what frequency I was hitting, again due to quirks with early software and numbers showing up that I'm pretty positive weren't actually accurate. But I think the GPU was operating in the 1660 to 1680 MHz range, topping out at just over 1700. I did encounter some instability as well while I was going through these benchmark numbers, but I've still decided to include them because they did improve my performance by about 5 to 10% when it was working, and I wanted to give at least a starting out idea for how performance might improve with Vega 56 when third-party cards with better cooling options arrive. With all of that said, here are my benchmarks. So guys, I know I didn't talk you through the benchmarks this time, but I think I will do that for the next video when I cover VEGA 64. Honestly though, these were some of the closest numbers I've seen with two similarly priced graphics cards. Generally speaking, the 1070 kind of shoots the gap between a stock and an overclocked VEGA 56, which would make them very competitive at the same price. There is a bit more to the story though, starting out with power draw. Now I measured power draw at the wall, I got an average while gaming with 3D Mark, and I also did the peak power draw across all of the testing that I did. VEGA 56 overclocked got pretty power hungry, hitting as much as 487 watts max power draw. That is while overclocked though. Now VEGA is a higher TDP graphics card though, with two 8-pin PCI Express power connectors and varying board power settings depending on whether or not it's water cooled, what power profile you're using, and if you switch to the secondary V BIOS, which is tuned specifically for lower power usage. I ran my VEGA 56 with the main V BIOS and the turbo profile because I'm more interested in performance and efficiency right now. That means I'm using 190 watt power profile, but all of these values kind of go out the window when you start overclocking. As you can see from my average and peak power draw numbers, the ramp up is pretty significant when you overclock. I haven't tested these lower power settings, but my impression was that VEGA can be very power efficient as a GPU, just not while running at the frequencies that also produce good benchmark results when you compare it to NVIDIA. Now as for temperatures, both of these cards got pretty warm, hitting 80 degrees or more on the GPU while benchmarking. The temperature increase while overclocking the VEGA 56 might seem minimal here, but remember that I was also running the fans at close to max, meaning that they were also pretty loud at the same time. Speaking of loud though, unfortunately I didn't have time to run official sound meter testing for this video, but anecdotally I can tell you that with the basic turbo setting, the fan noise for the VEGA 56 was just fine. Not quiet, but well within acceptable noise levels for gaming. When overclocking, however, well, a blower style fan running at 4,500 RPM might as well be a small vacuum. Let's just put it that way. As for frequencies, again, there was some weirdness with the monitoring software, but my card was able to hit the same frequency from what I could tell as the VEGA 64 liquid cooled when overclocking, which is supposed to be about 1677 megahertz, but my card was at least up in that range. When not overclocked, it was pretty stable as far as I could tell at 1590, which is the reference speed. So overall, now that VEGA is finally here, is it living up to the hype? I would say not really, but that's mostly because there was too much hype and it was drawn out over way too long a period of time. It's also totally fair to point out that AMD is competing with NVIDIA's cards from last year. The GTX 1080 and 1070 launched up May 27th and June 10th, 2016 respectively. AMD's cards, launching 15 months later, are competitive when it comes to performance and pricing, but not quite so much when you also consider power draw and launch timing. I also noted that the 1% and 0.1% lows weren't looking quite as good for VEGA in my testing. It did improve when overclocked, but hopefully those numbers will also smooth out as we see some driver updates, as the drivers, we can also assume, are pretty early at this point. On the plus side though, it is very good at least to show that the VEGA 56 is very competitive with the GTX 1070 at all resolutions, so if power draw is less of a concern for you, then it's a very viable option. Even more so when you look at the complete picture, which includes not just your GPU and your computer, but also monitors, as FreeSync monitors are just way more affordable than NVIDIA's G-Sync alternatives, often by $100 to $400 or more. If you're buying a GPU and a variable refresh rate monitor, the FreeSync option with VEGA is just a much better price to performance choice. If we're really looking at the whole picture though, we have to also include cryptocurrency mining, and that could very well destroy any hope that the common gamer has for getting one of these GPUs at the actual retail price. There's still a lot more to be said and questioned when it comes to this VEGA launch, I'm sure, in the next few days and weeks, but for now I'm going to cut this one off and continue my work in the VEGA 64 benchmarks. If you guys have any comments or suggestions for that coverage, please leave those in the comment section down below. Subscribe to my channel, and don't forget to turn on those notifications too if you don't want to miss when I post my next video. Hit the thumbs up button on your way out if you enjoyed this one. Thank you guys as always for watching, and we'll see you next time.